Hey, welcome to your second video lesson. Remember, this is hopefully being copied Friday night, Saturday, or Sunday, and then I'm not going to be here on Monday, so you're going to be working on the seat work for this lesson on Monday. The focus of today's lesson is working with midpoints of lines and then working with the equation of a circle. Our learning goals: use the formula for midpoint, calculate the midpoints, use the formula for an equation of a circle, and determine the equation of a circle centered at the origin, so 0, 0. And just like yesterday, for today's lesson, if you have your briefcase out, you should be recording all of the formulas in that briefcase or formula sheet. So we're going to start with the formula for midpoint of a line segment. And that little picture, you might want to copy it down. Midpoint, halfway point of a line. So on the left side of that midpoint is the exact same length as the right side of that midpoint. Our formula. So capital M. Yesterday for slope, small m. Today for midpoint, capital M. So capital M. And then subscript, you're going to put whatever the 2 points of your line segment are. We'll just say AB. So that tells the reader, find the midpoint of AB. And midpoint's like finding an average. If you can remember that, you can remember the formula. What's the average of my x coordinates? What's the average of my y coordinates? So x1 plus x2, all divided by 2. How do you find the average of 2 numbers? Add them and divide by how many there are, which in this case are 2. And y1 plus y2 divided by 2. And it's important to note that midpoint doesn't give you like a value, say like distance or slope. It actually gives you coordinates. So our first example, find the midpoint of each line segment. It might help you, don't have to, it might help you to write down the coordinates. So A's got negative 4, 2, B is 3, 2, C has got negative 4, negative 1, D is negative 4, negative 4, E is 1, negative 1, and F is 4, negative 5. So let's start out by finding the midpoint of AB. So capital M, subscript AB. You don't have to rewrite the formula, or at least I'm not going to through the lesson, but for you to help memorize it, you should be writing the formula down every single time until you have it memorized. It does not matter what you call x1 or x2, as long as if you start in point A for x, you start in point A for y. So x1 plus x2, negative 4 plus 3 divided by 2, and y2 plus y1, or y1 plus y2, 2 plus 2, divided by 2. Negative 4 plus 3 is negative 1/2, and 2 plus 2 is 4, divided by 2 is 2. Now negative 1/2, that's a nice decimal, so if you want to write it as 0.5, you can. I'm going to leave it as a fraction. Now we're going to find the midpoint of CD. Negative 4 plus negative 4, your 2 x coordinates, and negative 1 plus negative 4, your 2 y coordinates. Negative 4 plus negative 4 is negative 8, divided by 2 is negative 4. And negative 1 plus negative 4, so negative 5 divided by 2 is negative 2.5. When you are doing these on your own as well, it's probably a good idea to, if you have a sketch or a graph like we do, even if it's not to scale, to make sure that your midpoint actually is on the line. So if we look at like AB, for instance, negative 1/2, 2 is approximately there. Does it, first of all, is it on the line? Yes, it is. Does it look like it's halfway? Pretty well looks like halfway to me. Same thing here for CE. Negative 4 and negative 2.5, right there. Does it look like it's halfway? Is it on my line? The answer is yes to both. If you would have graphed it or plotted that point, it's like somewhere else, then obviously you've made a mistake. Finally, midpoint of EF. By 2 x coordinates, 1 plus 4, divided by 2. And then your 2 y coordinates, negative 1 plus negative 5, divided by 2. 1 plus 4, 5 divided by 2, 2.5. And negative 1 plus negative 5 is negative 6, divided by 2 is negative 3. And you can see for the last two, I wrote it as negative 2.5 and 2.5. If you want to write it as negative 5 over 2 and 5 over 2 for this one, you can, just to show you that you can write it as decimals or you can leave it as fractions. I'm assuming most of you prefer decimals, that's why I switched it up. And then double check to make sure that point's on the line. So 2.5 and negative 3 definitely is on my line. Does it look like it's in the middle? Yes, it is. We can be reasonably certain that that probably is our midpoint. Our next example, now there's no picture. I give you the coordinates, so find the midpoint of the line segment with endpoints A and B with the coordinates shown. Exact same formula, capital M, A, B, by 2 x coordinates, 3 plus 7 divided by 2, and my 2 y coordinates, negative 1 plus 5, divided by 2. 3 plus 7 is 10, 10 divided by 2 is 5. Negative 1 plus 5 is 4, 4 divided by 2 is 2. Now this one you don't actually have a picture to see if it actually is on the line, so if you were doing a self-check, you could very well do a quick sketch and see if that point is on there. For the next one, I want you guys to try that on your own. So you're looking for the midpoint of JK. So at this point, if you want to pause this, try this on your own, make sure you get the right answer. And when you unpause it,
Grant Eckenviller to the office, please. Grant Eckenviller to the office. Thank you.
so pause it, try it on your own, unpause it, and if you've done things correctly, you should have got 3.5 for your x coordinate and 0.5. Raise your hand if you got that right. Good work, everybody. Our next example, we have a word problem. On one endpoint of the line segment is at P, negative 3, negative 1. The midpoint's at 1, 1. If the other endpoint is Q, what are the coordinates of Q? So we have a little bit of a word problem, a bit of a thinking question. You need to figure out what the other endpoint is given the midpoint. So still start out like you normally would. So midpoint of PQ. And we know it's, let's start out by writing our formula. X1, X2 over 2, Y1 plus Y2 over 2. And then fill in what you know. We know midpoint gives us a coordinate. And we know that the midpoint of PQ I gave you is M, 1, 1. So we're going to put 1, 1 in there. And it doesn't matter what you call x1 or y1. In this case, we're going to use the x1, y1 as point P and the x2, y2 as point Q. So we know that point P has an x-coordinate of -3. I don't know what the other one is. That's my x2. And I know the point P, the y-coordinate is -1. And I don't know what the y-coordinate is of point Q divided by 2. From here, all you're doing is setting up two equations and playing match game. So basically, we know that the x-coordinate should be equal to all of that, and we know that the y-coordinate should be equal to all of that. Working with the x first, 1 equals -3 plus x2 over 2. How do you get rid of that 2 on the bottom? Cross multiply. 2 equals -3 plus x2. Bring that -3 over, becomes 2 plus 3. Which means x2 is 5. We're going to do the exact same thing with the y-coordinate. We know that it's 1, and we know that it has to be equal to -1 plus y2 over 2. Cross multiply, 2 equals -1 plus y2. Bring that -1 over, becomes +1. I'm going to skip a step here. 2 plus 1 is 3. 3 equals our second y-coordinate. So what does that mean? That means that point Q, so therefore Q equals x-coordinate, we got 5, y-coordinate, we got 3. So 5, 3 are my coordinates. If you want to double check your answer, you could put 5 in for x2. 5 minus 3 is 2. 2 divided by 2 is 1. That's what it should be. And you could put 3 in for y2. -1 plus 3 is 2. 2 divided by 2 is 1. That gives us our point 1, 1. So we just checked it, and it works. Any questions with that one? Good work. Equation for a circle at the origin. Origin, if you don't know what that word means, that means 0, 0 on your graph. This is going to go into your formula briefcase. X squared plus y squared equals r squared. In that little picture, you can see any point on that circle has x and y coordinates, and r, if it's centered at the origin, 0, r is our radius of our circle. Our first circle example, write the coordinates of a circle centered at the origin with radius 2. So, x squared plus y squared, I gave you the radius, 2 squared. What is 2 squared? 4. Oops, that should say 4, not r squared. So x squared plus y squared equals 4. Write the coordinates of a circle centered at the origin with radius 4. Same idea. X squared plus y squared equals 4 squared. What's 4 squared? 16. So x squared plus y squared equals 16. And there is our equation for both those circles. Pretty easy stuff. And the next application, sketch a circle defined by that equation. The first thing you're going to have to do is, if that's r squared, to get the radius, you're going to have to square root that, which means you're left with 3. So to make a quick sketch, y-axis, x-axis, and let's put 3 and 3 and -3. -3. So there's basically our outer boundaries of our circle. And you're going to do your best to make a nice circular shape. All that matters is that you have those 3's labeled there so everyone knows that the radius is 3. Example 5. Again, a little bit of problem solving here. A circle centered at the origin passes through the point 8, -6. What is the equation? First thing, centered at the origin, when you see that, you know you're going to start with this. And for the sake of this course, you're never going to see, or you shouldn't see, anything that's not at the origin. If you do, I can show you, but I'm never going to test you on that. So we don't know what the r is. We don't know what the radius is. However, I gave you a point that's on the circle, and we know it has coordinates x and y. So let's put 8 in for x, -6 in for y, and see if we can get the r value. So 8 squared plus -6 squared equals r squared. 8 squared is 64. -6 squared is 36. 64 plus 36. 100. Now what do? What undoes squaring something? Square root. And we're left with 10 equals r. Now that gives you the radius, so we know the radius is 10. Really, we didn't even have to do that step because we know the equation is supposed to be r squared, so we're just going to take this 10 and square it. So realistically, we could have stopped at this step, because r squared equals 100. And there is the equation for the circle that passes through that point and is centered at the origin. Any questions? Nice. Example 6. A stone is thrown in a pond that creates an outward ripple. The radius of the ripple increases by 5 centimeters per second. Find the equation after 12 seconds. I'm going to put a star beside this one. It may pop up, or something similar to this question may pop up again in the future. So where do we start? We know that if it's going to create an outward ripple, if we look at the picture, basically it's making concentric circles. So we know our equation is x squared plus y squared equals r squared. Now, the radius of the ripple increases by 5 centimeters per second, and we want to know the equation after 12 seconds. So, if anybody has any ideas, we know that if we take 5 centimeters per second, and we multiply that by the amount of time, it's kind of like a speed times time gives us distance. So if we do 5 centimeters per second times 12 seconds, we are going to be left with 60 centimeters. 5 times 12, 60 centimeters. The seconds cross out, that's how we know we're just left with centimeters. Once you know that, you know the radius. The radius is 60 centimeters. So to plug that into your equation, x squared plus y squared equals 60 squared. And 60 squared, if you use your calculator, you should get 3,600. And there is the equation of the circle, 12 seconds after the stone has been thrown into the pond. Any questions with that one? Again, you might want to start it, make sure you know how to do it or have the idea behind how to do it. You might see something similar, somewhere important coming up soon. So that is it for your second video lesson for Monday, midpoints and circles. We're going to start in classifying shapes Wednesday, Thursday. Friday you're going to have a quest. And then Monday you're going to eat a bunch of turkey, and then I'll see you again on Tuesday. And then we have our assessment days written there in that orange cloud for you. And I guess I will see you at the pep rally on Monday. And remember, on Monday, You can copy this down if you want, but really ideally, this is meant to be classwork completed on Monday. Have a great weekend. See you later.